right, section 1.1 is parent functions and transformations. So functions that belong to the same family share the same characteristics. The parent function is the most basic function in a family. Functions in the same family are transformations of their parent function. So right now I'm just going to show you 4 of them. As you get on farther, you'll hear some of your other teachers will say something about the big 8. Well, this is 4 of them. We'll get through 3 more of them. The only one we won't get to is the logarithmic one, but you'll get that next semester in trigonometry. So let's go ahead and get started here on the ones that we have. So the first one here is called the constant family. And for the constants family, the rule is f of x is equal to 1. All right, so what that is saying here is that I'm going to, no matter what x is, y is going to be 1. Now, I think they chose that to be your constant because if you didn't, it would have been the x-axis, and I think they want you to see that it is actually constant, and sometimes people confuse it when it's on the x-axis. So that's the graph of it, all right? And then I'm just going to keep doing everything here for you. So the domain is your input or your x values. All right, so there's 3 ways I'm going to show you. The first one is the way colleges have asked us to, at least the college here asked us to show you. The second 2 are kind of ones that you can see. So, and those will probably be the ones that you'll see more when you're doing it on big ideas in online. So the first one, the domain is all real numbers. So what we're saying there is it's negative infinity. Well, here, let me go back to the color I had. So it's going to be negative infinity to positive infinity. All right? Or like I said, you could say it's all real numbers. And I'm just going to use the number sign there, or hashtag. It was a number sign before they started calling it a hashtag. And then sometimes you'll see it as this fancy script R. Okay? The output is your Y. The range is your output. And that is your Y values. So if we look here, what that is saying here is if I follow my Y values, all right, well, that was my X values I just showed you. If I look at my Y values, well, no matter where I'm at, it's just going to be Y is equal to 1, all right? So on this one here, it is Y is equal to 1, all right? So our next one is called our linear one, and we'll notice that we'll know at least a couple of these, or we'll recognize them from Algebra 1. The linear one is f of x is equal to x. And if you remember, on this one here, when x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 1. When it's 2, 2, 3, 3, 4, 4, negative 1, negative 1. When x is negative 2, it's negative 2, and so on. And then there's our line for that one. Okay. And you won't be able to do it on the website, but when you're taking this SBAC test, they're going to ask you to do such stuff like that. Okay, so make sure you understand how to do that. Now, again, let's look at our x values. So our x values are going to be this way here. Well, as we can see here, if we keep going in our x direction, all right, we're going to have all real numbers. So it's going to again be negative infinity to positive infinity. And again, we could say are or all real numbers. I'm not going to do every single one, so this is probably going to be one of our longest ones anyways. So I'm just going to leave it there. Okay. Our next one is the absolute value function. And with that one there, it is going to be f of x is equal to the absolute value of x. So it's like the two little goalposts that the x is in between. And remember what that is saying, whenever we have something that is positive, it stays positive. If we have an x value that's negative, the absolute value makes it positive. So when it's 0, 0, when x is equal to 1, y is equal to 1, x is equal to 2, y is equal to 2, and so on. When x is equal to negative 1, the absolute value of negative 1 is positive 1. When x is equal to negative 2, the absolute value is negative 2, and so on. And then if we're going to make that one there, okay. So again, on this one here, what is our domain, our x values? As you can see, it's still going to be negative infinity to positive infinity, or all real numbers. Oops, I forgot to tell you what the range was on the linear one. Well, if you look, it's also all real numbers, right? Because it's not going to change. On our absolute value function, though, it's going to, if you look at it, so remember, the y values are, like I'm going up here, and once I can touch something, notice I don't touch something until when I'm at 0. And then when I'm here, it's still going to keep going up. I'm going to have something over here. So when I do this, I'm still having one there or one there. All right. So if you look at it, for that one there, if we want to use what the college likes us to do, we're going to say, well, we use a bracket when it's equal. All right. If it wasn't equal to it, we would use a parenthesis. We always use a parenthesis with infinity. All right. So on this one here, we would be saying it would go from 0 and include 0 to infinity, or we would say that y is greater than or equal to 0. I'm telling you that one because that's probably going to be our answer on big ideas. Okay. Oh, and I didn't change my color there. Oh, well, that's okay. And then finally, our last one here, all right, is going to be our quadratic function, which we should still again remember. That is our parabola. And that one would be f of x is equal to x squared. So on that one there, and I'm going to keep going because I kind of noticed my face is in the way there. When x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 1. When x is equal to negative 1 times negative 1 is 1. When it's 2, y is 4, or our f of x is equal to 4. And the same when we are at negative 2, negative 2 squared is again negative 2 times negative 2. So we would have something that looks like this. And remember, that's a parabola. Okay. So on that one there, what is our input? Again, our input follows our x, right? So if we're going here, our x, it's going to hit it every single time. We notice it's not there, but because I'm going here, but remember, it's kind of going like that. So it will still be all real numbers. Remember, I'm sure your book is going to want that one. And what is our domain, our output on that one is the same thing. We're going to say it's 0 to infinity, including 0. But again, I'm sure our big ideas, they're going to want you to say y is greater than or equal to 0. Okay, example 1. Identify the function family to which h belongs, and then compare the graph of h to its parent function. So here, real quick, ladies and gentlemen, here's what I want you to notice. Okay, whenever I do my notes, here's what I do for you. This one here says example 1. So if you don't understand this one, I always use the one that is different than the one in the textbook. So if you're saying, oh, wow, I don't understand what Mr. Baumeister just did there, well, you can always go to section 1.1 and look in your textbook and look for that example 1. All right? I always try to do one that is different. Okay? So let's go ahead and look at that. And let's see. It says h of x is equal to negative 3 in parentheses x minus 2. So what you need to see there, which one does it look like? Well, it does look like a linear one. It's kind of backwards, so it has negative slope, right? And then it's shifted. So let's kind of look at how it is shifted. All right. So I'm sure everybody will agree with me. It is linear. All right. Now, if it was our regular one, we would have something that looks like this, right? So that would be f of x is equal to x. So now let's kind of see what happened. Well, this one is going up, so we know it's positive slope. This one here, though, is going down, so we know it has negative slope. And then we're going to talk about shifted, okay? We're going to get more into this tomorrow, but you're going to see that if I start at my 0 there, okay, and I can tell which way it's shifted. So here, if I go from here to get to that other line, I would go 2. 2 units what? So it's shifted to right, all right? So if it was just on our regular homework, I would let you say just 2R, because R means right. I'm sure on the textbook, on the Big Ideas Online, it's going to have you. I'm sure most of this is going to be a drag and drop. Like I said, I haven't really seen this. I'll see it more with you guys than I did with last semester. So I'll be able to kind of see it. But remember, just in shift left or right, it also can shift up or down. And if we look there, it goes 1, 2, 3, 4, 5. It actually shifted 6 up. And like I said, we're going to get to know this stuff really better as we go along. Okay? All right. Page 2. A transformation changes the size, shape, position, or orientation of a graph. A translation is a transformation that shifts a graph horizontally, all right, so left or right, and or vertically, which is up or down, but does not change its size or shape. Example 2, graph g of x is equal to x plus 1 and its parent function, then describe the transformation. Well, remember, it has those kind of goalpost things there, so this one here would be an absolute value. So every once in a while, what we can do is we can go ahead and make a table. So let's go ahead and make a table here. On the first one. On the second one, we're going to do a graph. All right? So our x, I always tell people to choose some numbers. I always choose negative 2, 0, negative 2, negative 1, 0, 1, and 2. I might need to change that as time goes on, but with this one, I think it'll work fine. Now remember, g of x let's just call it y. You'll see here in a second. It's because y, remember, g of x is just a fancy way of writing y. So we can write that as y is equal to the absolute value of x. All right? And if I do that, remember what it does is, all that does is it takes the negatives and makes them positive. And the positives stay the same. All right? So now we're going to look at that one there, and now we're going to add a 1 to it. All right? Now I want you to think, we're adding a 1 to this. So negative 2 plus 1 is negative 1. The absolute value of negative 1 is 1. Again, using this. All right? Negative 1 plus 1 is a 0. The absolute value of 0 is 0. And so on. All right? So if we started with our regular one here, 0, 0, when x is negative, when x is 1, y is 1. When x is negative 1, y is 1. When x is negative 2, y is negative 2. All right, and so on. So on this one here, this is our parent function. And that would be, again, f of x is equal to the absolute value of x. And let's go ahead and do our other one. So when x is equal to negative 2, y is equal to 1. When x is 1, y is 0. And again, it's just going to follow the same V shape. So once we get a couple of them there, we're good to go. And remember, you should be able to tell me the difference between them. So g of x is equal to the absolute value of x plus 1. And now it's just asking you what we did here. So we went left to right. So on that right there, it is going to be a horizontal translation. And which way did we go? Well, there's our 0, and we ended up going this way. So we went 1 unit left of the graph of the parent absolute value function. All right? So we're just looking at a couple of these things as we go along, and we'll look at some again tomorrow. So a reflection is a transformation that flips a graph over a line of reflection. A lot of the times, it's going to be over the x direction or it's over the y. Sometimes it could be both, and we're going to be able to see that. And sometimes it could be over another line, like the line y is equal to x. But we're going to start out slow here. So it's always the same distance from the line of reflection, but on the opposite side of the line. Example 3. Graph k of x is equal to negative x and its parent function. Then describe the transformation. And this time we're going to use a calculator. I'm going to kind of show you real quick how to do that when I get there. But let's go ahead and, well, remember the parent function. All right, so here, let me use a different, I want to use my red for the transformation. So let's go ahead and remember, it's linear, so if x equals 1, y equals 1, etc., etc. Okay, and then there's our graph for that one. And that is f of x is equal to x. All right, so now we're going to use the calculator, and I have it set up here. We usually use, I'm going to use Desmos for you because that's the one that Big Ideas uses. It's not the perfect one, so if you have another one, but I also show you how to do certain things with this one. If you can figure it out on your calculator, awesome. If we were in the classroom and able to use my other ones, I like it a lot better, but we have to go with what we have, ladies and gentlemen. So let's go ahead here, and I'm now on Desmos, and you should have a free copy of it in your Clever. So I'm going to add an item, and I'm going to add an expression. Okay, so now on here, if you notice, I already have, oops, that's not what I wanted to do. Oops. Every once in a while, if I make a mistake, I'm not going to try to finish. I'm not going to try to do it. So here, if we look, we can just type in F. So you see the ABC there. Okay, I can click on that, and it'll give me the F. All right, so I can go F. And then, since it was in parentheses, we would say f of x. And then we're just going to say equals x. We could still use y also, ladies and gentlemen. But again, kind of look at what I just did there. Why did it just, oh, okay, I see, because I accidentally put an x times an x. All right, so if you look at it, when we go here, when x is equal to 1, y, or f of x was equal to 1. When x is equal to 2, our g of x is equal to negative 2. All right? So on this first one, I'm just using the ones that they said. But I want you to realize, if you just want to, you can even put y on both of these. Y is just a fancy, f of x, k of x. Remember, I just told you that's a fancy way of writing y. But on ours here, they said on this example, they said do k of x. So I'll go ahead and do k. Oops. Let me go and add one. I'm sorry. So we're going to number 2 here. So we are going to go k, parenthesis, x, close parenthesis, equals. And on this one here, your negative and your minus sign are the same. So I'm going to say negative, and I'm going to go x. And what did you notice there? It did change, and it's a purple one on this one here. I wish they would have had like a different color there, but I've already I'm going through a bunch of them, so I probably already used other colors. So if we look at it, what we have here is we actually have a reflection, all right? So we have a reflection, and in this case here, I want you to think here. Here was our 1, so if I look at that point there, all right, our point 1, it reflected it down here, right? So that one there is negative. So it did flip it over the x-axis, but with a linear one, it will also flip it over the y-axis. So if I'm at the point 1 there and I go here to here, it's also flipped it a negative 1. So in this case here, what we do have is we do have a reflection. So let's go ahead and graph it here too, I'm sorry. So remember, at 0 was still the same, but everywhere else, it was just a negative. So we're going to have something like this. And this one here is what they call k. Yep, k of x is equal to negative x. So in this case here, we had a reflection. And in this case, I just showed you how it was in the x-axis or the y-axis of the parent. What kind of function did we have? We had a linear function. Okay, and now finally our last page. Again, I told you the first one was going to be a little long, and I do apologize for that. So we can also stretch or shrink a function by a scale factor of a. So what we would see there is we would have something like g of x is equal to a times f of x. Notice how the A is on the outside. That's going to become important to us here later on. All right, so if our A is greater than 1, it's going to be a vertical stretch. And if it's between 0 and 1, that means it's going to be a fraction, all right, where the numerator is always less than the denominator, then we're going to have a shrink. Okay, so on the first one here, again, I'm asking you to make a table, and on both of them. So let's go ahead and see what happens here. So on A, we have r of x is equal to 3x squared. So again, let's make a table, and let's not make it red because I'll keep the red one for what our transformation looks like. So we're going to have x, we're going to have f of x is equal to x squared, and then our last one, our r of x is equal to 3x squared. Okay, so again, let's just go ahead and start with -2, -1, 0, 1, and 2. When I squared it, remember it was 4, it was 2, it was 0. Excuse me, it was 1. Sorry. Jumping ahead of myself here. All right, and then it was 1 here, and then it was 4 here. So let's go ahead and graph that again. So when it was 1, 1, when it was 2, it was 4. And when it was -1, it was 1. When it was -2, it was 4. Remember, that's symmetrical. We're going to use that name again, which we've already used before. We even used it in geometry. And that is our f of x is equal to x squared. So now remember, what 3x squared does is it's taken our x squared, so it's taken our answer here, and it is multiplying that by 3. So in this case here, and why don't I go ahead and put it in red here. So 4 was our x squared, so we have 3 times 4, which is 12. We'll have 3 here, we'll have 0, we'll have 3 here, and we'll have 12 here. Okay? So if we look at it, at 0, it's still 0. When it was at 1, it was at 3. So 1, 1, 2, 3. When it was at -1, it's at 1, 2, 3. And if it's at 12, at 2, it's at 12, right? So if we did that, you would see we'd be off. 1, 2, 3. I have us at 9, so we know it's going to be up here somewhere. And if you notice here, I have that, and let me go ahead and tell you that was what? F of x, R of x is equal to 3x squared. So now, here's what I want you to picture, okay? First of all, we know our A, which is equal to 3. If we look up above there, we said if it's greater than 1, it's a stretch. So it's a vertical stretch. So now what I want you to think is what we're doing is we're taking those arrows on the blue one up there and we're pulling them, all right? We're stretching it. Think of it as a rubber band that I just cut up, all right? I'm taking those 2 arrows and I'm stretching it, so it is kind of making it narrower, but it's called a vertical stretch, all right? So if it's making it narrower, think what's going to happen when we do one like the next one here, it is going to make it wider. All right, that's the easiest thing to remember. All right, because again, what we're talking about is in relationship to the x-axis. So let's go ahead and do this one here. So again, let's see, we have our x, and then we have our f of x is equal to the absolute value of x. And then we're going to take that and we are going to say that our p of x is equal to 3/4 of the square root of x. All right, so same thing. I think on this one here though, let's see, I've decided to go by twos, and hopefully you'll see why. So I used -4, -2, 0, 2, and 4. All right. Again, absolute value of x just makes it positive when it's negative. And now it's saying take 3/4 of the absolute value of x. So on this one here, what they're doing is they're telling us to take 3/4 of my value of x. In this case, it was 4. Right? Because we already used that absolute value sign there. And now I want you to kind of see those cancel each other. And on this one here, I'll have 3. Okay. When it's 2, you should have 1.5. And 0, we're still going to be the same. At +2, we're going to have 1.5. And at 4, we're going to have +3. So let's go ahead again and do both of them. So our f of x, again, when it's 1, 1, 2, 3, 4, still a V shape. Remember, V shapes and U shapes will have symmetry. Again, we'll get to that more. So that was our f of x is equal to absolute value of x. That's our parent function. And I think they're asking you to do that on your homework too. All right. And then let's see on this one here. So when it's 0, it's still 0. When it's at 2, I told you it was at 1.5. So if you think it's not the best graphs I had, I do apologize for that. When it's 4, 1, 2, 3, 4, it's up 1, 2, 3. So it is, notice it is outside, it is wider. And that is our p of x is equal to 3/4 the absolute value of x. And we should be able to find those there. And then finally, you can also use more than one transformation to change the graph of a function. This time again, I'm going to use the graphing calculator for you. And it says, example 5, use a graphing calculator to graph h of x is equal to -0.25 x squared plus 4 and its parent function, then describe the transformation. So remember, on our parent function, it's got a squared there, so we know from up above it's a quadratic function. All right, so again, I should have 1, it's 1, and when it's 2, it's 4. When it's -1, it's 1. When it's -2, it's +4. And we'll have something like this. All right. So now, on the other one, let's go ahead and go back to our calculator. And we'll put both of them on there too. So So again, to get rid of these, if you don't want to see them anymore, let's just exit out. And this time here, let's go ahead and, here's part of my problem is that I know somewhere down below, I can get rid of that, that's right. See, I'm still learning stuff every once in a while, all right? So on this one here, let's go ahead and let's just call it y this time, because remember, I told you we can still call it y equals. And on this one here, it's just x squared. So let's go ahead and do our regular one. So there's our x. And then we're going to square it. So there'll be our squared. So where it says a squared, notice there now it did give us a nice function, which we would expect it to do. All right. Then go down here and click on this one here. Again, we're going to call it y equals because we can. And then on this one here, we're going to do exactly what it says. So it says negative, all right? And then it has 0.25. Remember, that's 25 hundredths, okay? And then we're going to have x squared. And then we're going to have plus 4. All right, and why isn't it working? Oh, because I have two equal signs there. Interesting. So look, I'm teaching you stuff. There we go. I was worried for a second there. So notice what happened here. Okay, it flipped it over the x-axis. All right, so that gave us a reflection in the x-axis. All right, remember it made it wider, so that would be a vertical shrink because remember our a is between 0 and 1, okay, and then it went 4 up. So remember that there, and in fact kind of remember our pictures there. So look at a couple of points that would be easy ones to see. Well, we have 4, and we have them at the x-axis too. All right, so let's go back to our screen. All right, so I just told you we went up 4. And then I told you to remember it was at negative 4. And positive 4, it was at 0. And there is our graph for our h of x. So our h of x, negative, that was our reflection, or 0.25, which is less than 1, so we know it's going to be a vertical shrink, x squared plus 4. I forgot to put our parent function was f of x is equal to x squared. Let me make that squared a little better. All right, so then what did we just say? We have to describe the transformation. So on this one here, we're going to say h of x is a reflection over x, a vertical shrink again, I don't know how specific the big ideas is going to want you to be, but we'll definitely make sure. And it went 4 up. Okay, So remember, the reason we know it's a vertical shrink is that 0.25 is between 0 and 1. All right? Just like on this one here. Oops, I should have told you that on that. So A is equal to 3/4, and you know that 3/4 is between 0 and 1. So this one here was a vertical shrink. And that's why I can say a vertical shrink on the bottom one too. All right? Our notes aren't always going to be this long, ladies and gentlemen, but I'm done now, and hopefully you'll watch this and fill out your notes. Thank you.